So this particular bell work, what we're doing is just, in concept, it's pretty straightforward. We're going to plug numbers in and see what happens. All right, so I've got this expression right here that I'm going to just start plugging numbers into. So it's going to be 9 plus b is 5 minus, now I need to figure out what g is. G is -6. So this might be where you went wrong. If you just did -6 instead of minus a -6, that'll throw you off. Now this is times, and I can see where a lot of people put their answers in. Maybe you didn't realize we're multiplying these together. So b is 5 plus, it's still a plus, and then the g is -6. So the way that this works when we do this algebraically, or just arithmetically, just adding these together, 9 plus 5 is 14. 14 minus -6, minus a negative is the same as adding. So basically 14 plus 6 is 20. And then 5 plus -6 is the same as 5 minus 6, and that's going to be -1. So a lot of you guessed J, and that makes sense if you were adding these together. 20 plus -1 would give you 19. So that might be where that went wrong. But of course, it's not adding, we're multiplying. So 20 times -1 is just -20. And that was this answer right here. In first hour, a lot of people said -8. And you would have gotten that if you accidentally subtracted 6 rather than added a -6. Sorry, subtracted a negative. So added 6. So basically, if you subtracted rather than added, you would have gotten -8. So there's all kinds of reasons why you might get a specific answer versus another, but hopefully you recognize where you made your mistake along the way. And I do hope you guys are actually sitting there trying to come up with the correct answer when you do this. You're not just putting a random thing down, because that's going to help you as you get ready for the ACT. And I just want to mention right now, the ACT is useful for more than just getting into college, because if you've already decided what your future plan is, then the ACT might or might not help you toward those goals. But the ACT, if you're not already familiar, it will give you feedback on basically, here's how you performed in different areas. And knowing that, here are some careers that fit your skills. And you do this pre-enrollment. If you're junior, you're already probably familiar with this, but you do a pre-enrollment to kind of say, here's what my plans are. You take the ACT, they say, hey, your plans work perfectly with what your skills are. Or they might say, hey, maybe you're going to find that more challenging based on your skill set, but here's some other things to think about. Not to say you shouldn't pursue it, but you might find some difficulty. So the ACT just gives you a lot of good career advice and career feedback so that you can help make some plans. So do the best you absolutely can. If you've already decided you don't care about college, doing the best you can still help you regardless of what your choices are moving forward. All right. So today we're going to be introducing our 30, 60, 90 triangles. And well, let's break that. Let's just jump right into it. This is our other special right triangle. There's only 2 that we're looking at. There's only 2 that really are out there. And so once you know the rules about the 30, 60, 90, then you've gotten everything you need. And you can just practice on mastering exactly what those rules require. So just as a reminder, when we were looking at the 45, 45, 90, that was a square that was cut diagonally. And I'm not going to go through those rules. You should already be familiar with them. But now what we're doing is we're taking an equilateral triangle and we're cutting that in half. And this line that we create going from the one vertex straight down and perpendicular intersection down here, that's what we call an altitude. Now that doesn't matter, that term, but when we cut this in half, we create 2 triangles. And notice how we're coming up with this 30, 60, 90. This 60-degree angle up here at the top is now being cut in half into 2 30-degree angles right here. So there you go. When you're done, you have your 90-degree angle down at the bottom corner, the 30 and a 60. So there it is, 30, 60, 90. So we didn't just decide, mathematicians didn't just decide, hey, let's just pick a couple of triangles to learn some rules about. These are 2 that come from very common shapes, equilateral triangles and squares. And they're common as far as when we are constructing things. They're not common in nature necessarily, but they're common in how humans design things. So there are certain rules we can use. You already know the ones for the 45, 45, 90. It can make our calculations go a lot faster knowing those rules. So let's jump into the 30, 60, 90. Okay, so we're going to do this the same way we did before, which is we're going to do some Pythagorean theorem. And you already know going into this that we're going to be doing Pythagorean theorem and trying to come up with a set of rules that we can use. So we're looking for a pattern. So knowing that you're looking for a pattern right away, I'm going to see if you can maybe come up with that pattern from the very first triangle we look at. So if I look here, I've got 4, 8, and this unknown side right here, x. The way that I like to label my right triangle for the Pythagorean theorem is I go with the shortest side, I call it A. The longer leg, I call B. And then this right here is, of course, the hypotenuse. So anything, the side that's opposite the right angle is the hypotenuse. So I'm just going to run through that, and I put hypotenuse. I can put C right here. We need to remember A squared plus B squared equals C squared. And now we can just start setting this up and going through it. So I've got A squared is 4 squared plus my unknown B, which is x squared, equals 8 squared. All right, is everyone good with that? Any questions on how I came up with it? Okay. So 4 squared plus x squared equals 8 squared. That's all good. And now I'm just going to go ahead and start doing this. 16, 4 squared is 16. And if you forget that, and especially those of you in person, if you're trying to remember what's 4 squared, you know, the multiplication table right here, you just go to the 4 and you go down to that white box, and that's going to be the square of that number. So 4 squared is 16. 8 squared, if we look at that, is 64. All right, I'll have you guys shout out some answers, the numbers in a minute, but let's just run through this first one. So if I subtract 16, this is set up a little differently than the last Pythagorean theorem we did. Now we're solving for one of the sides, so I actually have to subtract the 16 away from both sides. X squared equals, well, what's 64 minus 16? 48, thanks. So now, of course, we want to take the square root of both sides. Now we're simplifying a radical. What's the biggest perfect square factor of 48? Four works, so I could do 4 times 12. But is there a bigger perfect square factor you can find? 8 is not a perfect square, but it is a factor of 48. Right. 36 won't quite work, but there is one that will. So 36 is too big. 4 works, but it's not the biggest one. 16 does work. And this is where I'm kind of assuming you guys are already familiar with simplifying radicals, since I've been having you practice it since the first week of school. But what we can do is we can keep trying. We can take 48 divided by 4 and we get 12. 48 divided by 9, we get some weird decimal. 48 divided by 16, and we get 16 times 3. Now we know that there's no other perfect square factor of 3. So at this point, we can decide, okay, we're done. So now we got 16 and 3, which gives us our final answer of 4 times the square root of 3, because the square root of 16 is 4. All right, so I'm going to write this down right here. So we've only done one Pythagorean theorem, but just if you look at that for a second, and I'll clear some stuff here so you can read it a little clearer. Looking at this, sorry, I erased that right there. Looking at that, does anyone already have a prediction about what they think this side length is going to be for the next problem? You can type it in the chat if you have a guess. So a guess was just thrown out. It's written on the screen here, 3 square root of 3. All right, let's see if that is correct. Okay, and maybe you can look at that and you can figure out why that is the guess that's made. Maybe you can agree that that's a good guess. Okay, regardless, let's go for it. So I'm going to do, this is A, B, and C. I'm going to just plug the x in to solve for it. So it's going to be 3 squared plus x squared equals 6 squared. That's 9 plus x squared equals 36. Subtract 9. And we get 27. I know I'm going through this quickly. So I hope you guys did your practice with the Pythagorean theorem so that you're not getting lost as I go through this. All right. So now, x, what's the biggest perfect square factor of 27? It's 9. There it is. So we got square root of 9 times the square root of 3. And now we can get our final answer of 3 times the square root of 3. So that was exactly right, that guess that was made. Now we knew we were looking for patterns. Maybe some of you were thinking that, but you didn't want to say anything out loud. But that's it. So hopefully at this point, now you guys are seeing the pattern. So we've got 4 square root of 3 is the answer for the first one. 3 square root of 3 was the answer for the second one. What do you think x is going to equal right here? 1 times the square root of 3. Okay. And if it's 1 times it, we don't actually have to put the 1, but it, yeah, just square root of 3. But I wanted to say it's not wrong if you do that. It's just unnecessary. So if you wrote that on a test, that's totally fine with me. All right. So we can just do this real quick. Here's A, B, and C. There's the hypotenuse. So let's just run through it. 1 squared plus x squared equals 2 squared. So that's just 1. And 4, we subtract the 1 from both sides. And we get x squared equals 3. And now we can just take the square root of that, and we have our answer. X equals the square root of 3. So we're always going to end up with square root of 3 for this other leg. So there's going to be an association there. There's going to be a rule that we can follow. Okay, so I want to point out a couple of things with this before we move forward. I'm going to use certain terminology when we're talking about the 30, 60, 90 triangle. When we were looking at the 45, 45, 90, I said, is it the leg or is it the hypotenuse? And hopefully you guys were getting that down. Now, I can't just say is it the leg or the hypotenuse here, because with a 30, 60, 90 triangle, I need to specify which leg I'm talking about. Am I talking about the short leg or the long leg? Well, here's my terminology I'm going to use. I hope you can follow along with this. I'm going to call the short leg the short leg. And I'm going to call this long leg the long leg. All right. So that's our terminology so that we can clarify which one we're talking about. We never needed to clarify that with the 45, 45, 90 since they're both the same length. They're congruent. Here they're not. So short leg, long leg, hypotenuse. And luckily it's a visual thing. So we're looking at a new 30, 60, 90 triangle and I say, which side do we have information on? You can see a short leg, a long leg, and a hypotenuse, and you can just answer accordingly. Now the rule, and I will clear some space right here so there's not too much competing writing on the screen. I've got my 60-degree angle right here, the 90 and the 30-degree angle. So the key to the 30, 60, 90 triangle is the short leg. So for the short leg, I'm just going to put an X. And if I know that the short leg is some value X, what can I do to find the long leg? So if we look right here at these examples, if the short leg was 4, what did I do to get the long leg? Here's the short leg there. What did we do to get the long leg? I'm not saying the Pythagorean theorem. What calculation did we do?
Multiplied it by the square root of 3.
That's it. So we multiplied by the square root of 3. So the reason I ask that is because imagine this is any value x. So now I'm looking at this right up here. Imagine that's any value x, and that'll change based on the problem. In order to get the long leg, I just want to take that value x and multiply it by the square root of 3. So we're going to have a rule related to this, and that's it. If you know the short leg, multiply it by the square root of 3, and that's the length of the long leg. Pretty straightforward. Now, we didn't ever have to calculate this. It was already given, but look at the relationship between the hypotenuse and the short leg. And what is the relationship between that? There it is. The long leg is twice as long as the short leg. So if we know the short leg, the long leg is just 2 times that value. And that's it. Okay. So let's talk about that one for just a second. The reason that this one will hopefully make sense for you, and I'm going to erase a little bit of stuff over here that we don't need anymore, just so it doesn't get cluttered. Now, when we're looking at these 2 triangles, this equilateral one up here, keep in mind the equilateral triangles, all sides are the same length. And what we did is we cut this in half with this altitude, with that line. So if I cut that in half, let's say that all these are side length 2x, 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 and 2x. Well, when I cut this in half, now it's going to be x and x. So just from that perspective, hopefully that makes sense why we have this relationship that we do. So anyways, if you can remember that visual of an equilateral triangle being cut in half, that'll help remind you of this rule. Now you'll still have a reference available for everything that you do, so you don't have to have it memorized, but it can at least help you understand why that's the rule. All right, so I am going to erase all this, but I should point, well, I won't point it out, I'll just show you. So let me bring this up real quick. You've got your 30, 60, 90 triangles homework on Delta Math. I'm going to go through a few examples on it, and then there we go. Let me get out of this, move over to here, and I wanted to show you, I added this yesterday, and everyone in the class, what I plan on doing is tomorrow, I'm going to have a paper copy printed off. You might find that helpful to have. But I put up a Unit 5 reference sheet. Okay, and now you can see the rules. We got the 30, 60, 90 triangle. This is showing exactly how we just did it, except flipped around a little bit. Here's the 45, 45, 90, and then down at the bottom, there are the formulas. So this is what it'll look like all on one screen. So if you want to have this reference available, then of course it is right there. I'll have a paper copy for everyone in the classroom, but if you're at home, you can either copy this down on a piece of paper or just have it available digitally. But I just wanted you to be aware that there is a reference. You do not have to have any of this stuff memorized. All right, and that's good to go. So let's jump over to Delta Math, and we're going to look at these types of problems. Okay, I'm going to find a simple one to start off with. You know, this one might not look simple, but it's really not too bad either. Well, no, we won't start with this one. This is a simple problem. And the question, of course, the first question we'd ask is this 45, 45, 90, or is it 30, 60, 90? we know all these are 30, 60, 90. So let's jump to the second question. Second question is, what do we know about this triangle? Do we know the short leg, long leg, or hypotenuse? We know the short leg. All right. So if we know the short leg, then that can help guide us. Now, I guess before we jump into this problem, I'm going to create this little reference right here. And let me see, that's 2 times x. Now, I wanted to create some formulas for us. Let's look at the relationship between the short leg and the hypotenuse. And you can see from this example, hopefully, that that's what we're looking at. We're looking at the hypotenuse. All right, so if we know the short leg, we can find the hypotenuse by multiplying the short leg times 2. Vice versa, if we know the hypotenuse, we can find the short leg by taking the hypotenuse and dividing by 2. Now, you don't have to use both these formulas. You can just pick one of them, right? We also have a relationship between the short leg and the long leg. And the way this one works is if we know the short leg and we want to find the long leg, I just need to multiply by square root of 3. So the long leg equals the short leg times the square root of 3. And vice versa, the short leg equals the long leg divided by the square root of 3. All right, so if you like having formulas available for you, that's on the reference as well. And you really pick one or the other. You have to decide which kind of equation you're going to use. This is going to be ones that involve the short leg and the hypotenuse. These involve the short leg and the long leg. Now, if this looks complex at first, I hope as we go through some examples, you realize, it's just, there's not too much to pick from, and we can make this calculation a lot easier than it might seem at first. So we already decided we're looking at the short leg. We're trying to find the hypotenuse. So look at this, short leg and hypotenuse right there. I'm going to pick one of these equations. It really honestly doesn't matter which one, but I'll go ahead and pick this one right here. I'm solving for the hypotenuse, so I'll make that all by itself. So the hypotenuse right here equals the short leg times 2. So the hypotenuse is the unknown x. The short leg is 4 times 2. And this is about as straightforward as it gets. All right, any questions on this? All right. Now, let's say, and we're just going to pretend that instead the x was not here, but it was down here. We're solving for this. Then I'll just run through this one. In that case, we wouldn't be solving for the hypotenuse. We'd be solving for the long leg. And that would be the short leg times the square root of 3. That's using this formula right here. And in that case, the long leg would be my x that's unknown. The short leg would be 4 times the square root of 3, and that's all we can do with this. So it's 4 square root of 3. Okay, so I'm going to go through a few examples, and then, of course, you'll have the rest of the class period to work on this. But let me erase all this, put the answer in. So the real answer to this question, because we were solving for the hypotenuse. Oh yeah, and the question just came into the chat. Basically, if you're trying to solve for the long leg and you know the hypotenuse, you do have to solve for the short leg first. So we'll definitely go through an example like that. It's a good question. But I'm going to just plug the 8 in. In fact, I'll find a question like that next. These are randomly assigned. You already know that. So we'll just keep going until we find a good question to answer. Okay, we got a green check mark. We're happy about that. All right. This one Actually, this is going to be a little bit more challenging than it seems, so we'll just jump into this one. Okay. So in this case, it's a 30, 60, 90. We know that, but what do we know? The short leg, long leg, or hypotenuse? We know the long leg. We're trying to solve for what? We're trying to solve for the hypotenuse. Notice we don't have a direct relationship, like a direct equation we can use for that. We could come up with one. We certainly could, but it's really not worth our time to do that because that just adds some extra complexity. And anyways, let's just first of all solve for the short leg. So I know the long leg. I'm trying to solve for the short leg. And so I'm going to use this equation right here. All right, that helps me solve for the short leg. And I'm just going to use SL from now on and LL. So the short leg equals the long leg divided by the square root of 3. I'm going to call this Y. I'm just creating my own variable there. The long leg is known, it's 2. All right, it's just plugging in numbers, kind of like we did in the bell work today. So I didn't want to put an equal there. We can't leave our answer like this, and I can't just divide 2 by the square root of 3. So can anyone remember what we need to do with this?
Multiply the square root of 3.
Okay, multiply by, let me do something real quick. Multiply by the square root of 3.
Divided by the square root of 3.
There it is, divided by the square root of 3. So this is, the actual process here is called rationalizing the denominator. But essentially we're just, multiplying by 1 so that we can get it to the form that we like. So there we go, very good. Now we can just multiply across. We multiply the numerators together. And what do we get there? Yeah, nothing too fancy with that. 2 square root of 3. Multiply square root of 3 times square root of 3, what do we get?
6.
No, 6. It'd be, yeah, square root of 9. And we know the square root of 9 is? It's 3. All right, now this is not our final answer. We just solved for this side right here, what we're calling y. So that's 2, oops, that didn't work out well. 2 square root of 3 over 3. And now we need to solve for the hypotenuse. So what do we have to do?
By 2.
There you go. We're just going to take that and we multiply it by 2. Oops. So really what I'm using is this equation right here. That the hypotenuse is going to equal the short leg times 2. So I'll go ahead and write that down. The hypotenuse equals the short leg times 2. It's going to be a weird answer, right? Because we have 2 square root of 3 over 3 times 2. And, well, 2 over what? Well, let me say it this way, because that might have been a confusing question. If I'm multiplying by 2, then 2 can be rewritten how? Yep, there it is. Any whole number can be written as a fraction, just that number over 1. And that's good to see because it's going to help us with the multiplication. All right, so now I can multiply across. What I'd recommend is you guys copying this work down or taking a picture of it when we're done so that you can see what the process was. So if you're just passively following along, but you're not taking any notes, you're going to run into some difficulty later, potentially. All right, so if I multiply, we know the denominator, 3 times 1 is 3. What's the numerator going to be here?
Square root of 3.
4 square root of 3. And this is where I've seen people making mistakes, so I want to make sure we point this out. If I have 2 square root of 3 times 2. That's the same as 2 times 2 times the square root of 3. I just rearranged it. And now you can just multiply those together to get our 4 square root of 3. So we're multiplying the like terms, which are the 2's, and that radical we just kind of leave off to the off at the end. Okay, so there it is. And that's pretty good. Okay, there's our final answer, 4 square root of 3 over 3. Let me plug that in. I will erase all this first of all. All right, sorry, need to erase. All right, there we go. We have a clean screen again. So it's 4 times the square root of 3 divided by 3, and there's my answer, and it was good. Okay, so that one you could tell was a little more involved, a little more complex. Let's go through 2 more examples, and sure, let's go with this one. Now this is, well, okay, what do we know in this problem? We know the hypotenuse, and what are we solving for?
The long leg.
There we go. So now we're basically going to work our way around the triangle that way. Okay, so to solve for the short leg, what are we going to do?
Divided by 2.
There it is. The short leg equals the hypotenuse divided by 2. So that's going to be our unknown y is 7 divided by 2. And in this case, we don't want to actually plug that in and get a decimal answer. We just want to leave it as is. So it's going to be 7 divided by 2. And that's what we can leave it as. All right, so let me go ahead and plug that in right here. 7 divided by 2. Now, if I know the short leg is 7 over 2, and I'm trying to figure out the long leg, what do we do?
Times by the square root of 3.
There you go. So thanks for answering. So hopefully everyone is looking at this. I have these reference formulas up on the screen. Of course, you can also just look at the diagram right here and kind of piece it together logically from that. But I know the short leg, I'm trying to find the long leg. I'm just going to multiply by square root of 3. So it's the short leg times the square root of 3. So the long leg is our unknown x. The short leg is 7 over 2. And I'm going to multiply that times square root of 3. And again, this can be written, any number can be written over 1. So what's our final answer?
Seven times square root of 3 over 2.
There it is. Thank you. Seven times the square root of 3 over 2. All right, so today and tomorrow is going to be practice with the 30, 60, 90. We're going to do one more example, and then I will let you guys practice on your own. Friday, we're going to mix it up. So I want to make sure you really have the chance to master the 30, 60, 90. It adds some complexity, you can see. But what's going to make it more challenging is on Friday, you're going to have 30, 60, 90 and 45, 45, 90, and you're going to have to go back and forth between your 2 sets of rules. You have the reference sheet available, but you need to know how to use the equations. All right, I'm going to end off with, one that's, okay, let's go with this one. This is going to be a good one to end with. All right. So now we've got this weird thing. We know I'm just going to run through this one, okay? Because we've done this quite a bit. We know the hypotenuse. We're solving for the long leg. So the first thing I need to do is solve for my short leg, which I'm going to call y. If I know the hypotenuse, I can solve for the short leg by taking the hypotenuse and dividing by 2. All right. So that is just this equation that's found over on the right side. You can see where that comes from. So the short leg y is going to be the square root of 8 divided by 2. Now, depending on what radical they give me, this might be as far as I can go. But we do want to make sure we're thinking through this carefully. And square root of 8, does it have a perfect square factor? I'll go ahead and tell you it does have a perfect square factor. What is the perfect square factor of 8? 4. There you go. So I can divide this into the square root of 4 times the square root of 2. Now you can see why I've been giving you all this practice with radicals, because, you know, you should have been doing all that work and mastering this along the way. So anyways, from here, I'm just going to keep moving forward. I've got square root of 4 is 2 times square root of 2 over 2. And this is where, using our algebra skills, we should know that if I have these 2's right here, I can just cancel them out. So our short leg, after that math right there, is going to be square root of 2 in length. So that's not my final answer. I actually want to solve for the long leg. So this is where I come over to these equations right here, and I pick out the last one. So I'm solving for the long leg, and I know that's going to be the short leg times the square root of 3. So essentially, my unknown value x is going to be square root of 2 times square root of 3. And this one's a pretty straightforward calculation. That's going to be square root of 6. Okay. So there we are. Let me go ahead and plug that in. It's going to be square root of 6. Hope I didn't make a mistake here. And we got the green check mark. Okay, we're good. So that is how we can run through this. Those are the examples I'm going to run through. If you want to see more examples, certainly you can stick around. We can certainly do that. If you have any questions as you're going through it, feel free to let me know. But there we go. That's what we've got with 30, 60, 90. Practice with that today, and you'll have some more practice with it tomorrow. All right, have yourself a wonderful day, and I'll see you then.